Hey everyone. So in this last video on visualizing logistic regression results, we're going to make things a little bit more complicated by adding an interaction between two predictors. Okay, so we're still in in this running example. We're trying to predict voting behavior, in particular in the 2000 U.S. presidential election. And now we're looking again at two different predictors. On the one hand, we have our ideological feeling thermometer that we've already worked with in previous videos, but now we have a second predictor, namely education, which is measured on I believe, a 7-point scale as well in this case. And we're looking at the interaction between those two. The hypothesis, for example, could be here, or the theoretical reasoning could be here, that for more highly educated respondents, there's a stronger correspondence between their ideological self-placement and their actual vote choice, right? So only among like more educated voters do we see like a clear correspondence between their ideology and voting behavior. Okay, so in order to kind of test this theory or this hypothesis, we would include an interaction term between the ideological self-placement, or this feeling thermometer that we've been using, and education. And again, the same caveat applies. We have education here on a 7-point scale, just for illustration. If we actually, we might consider different codings. Oftentimes when we work with education, we would potentially consider just a dichotomized version where we can compare respondents with college education versus no college education, or we might be concerned about other types of non-linearities by just using the raw education scale. But for the purpose of our analysis here, we'll just work with this original scale. Okay. One thing we will do, however, is we will mean center both predictors. And this is just a general advice that we also already talked about a little bit in the context of linear regression, which is as soon as you have kind of interactions, and in order to make those coefficients more interpretable, it usually helps to at least mean center, it doesn't have to be mean center, but center the predictors, right? So that having the predictor being equal to 0 actually has some meaningful substantive value. Okay, so the way we do this here is with two different centering operations. On the one hand, we subtract 50 from our feeling thermometer, which again ranges from basically 0 to 100. So that means we're not subtracting the mean, we're just subtracting basically the theoretical center of the scale from each observation. So now this new measure ranges from -50 to 50. And in order to make it better comparable to a 7-point scale like education, what we're going to do is we will divide it by 10. So 1 unit increase in this feeling thermometer is now basically a 10-point increase on this original feeling thermometer scale. Okay, so now this new ideology variable ranges from -5 to 5. Okay, and so we'll use that. We'll also center our education measure by just subtracting the median. If I remember correctly, I think that should be just equal to 4. So then the new education measure basically ranges from -3 to 3. The point here is that for both of those inputs, 0 has now a substantively meaningful interpretation, in the sense, or in the case of education, it means it's the median level of education across all respondents. And in the ideology case, this is the theoretical center of our scale, of our feeling thermometer that we've been using. Okay. In order to run this logistic regression in R, we just adjust our formula. We include this interaction term between this centered feeling thermometer and centered education. Again, we're going to save our coefficients in a vector. I'm just doing this basically to simplify the output in this markdown presentation. And then we're looking directly at the coefficients. Okay. Again, we can as a first step, kind of evaluate the direction of these associations. Okay, so again, we see for ideology, when education is at 0, so when education is basically at its median, we see a positive relationship. So comparing two respondents with who that differ in their ideology by 1 unit, which is now, remember, 10 points on this original feeling thermometer scale, we see an increase in the probability, or we predict an increase in the probability to vote for the Republican candidate. Okay, and this is estimated. Seems to be a fairly strong effect. We're going to talk about how to interpret this in the probabilistic sense in a second. But it's definitely estimated fairly precisely. The standard deviation is much smaller than this point estimate. Okay, different image, or a different view here for education. We see again a small, well, we see again a positive coefficient. Okay, so again, comparing two sets of respondents that differ in 1 unit by, or in 1 unit in this education measure. The point estimate suggests that there's an increase in the probability, but again, or in contrast to this ideological, the coefficient for ideology, here there's much more uncertainty around that estimate, and so this kind of comparison is much less clear, right? So we're not certain that an increase in education, or in this comparison, is also associated with an increase in the probability to vote for the Republican candidate, at least for cases where ideology is basically set at 0, set at the center of the scale. All right, so for in particular for moderate respondents who didn't identify as Republican, as conservatives or liberals. Okay. Lastly, we have our interaction term. This is positive, and we can basically look at it from two different perspectives. Either ideology moderating the effect or the coefficient for education, or the other way around, education kind of moderating the coefficient for ideology. From our theoretical perspective, in our example, we're more interested in education as a moderator for the coefficient of ideology. So I'm going to proceed kind of interpreting it in that way, right? If we want to do that, just looking at the direction, the positive coefficient on the interaction term implies that we already know that when education is equal to 0, then ideology is associated, or a 1 unit increase in ideology is associated with a larger probability to vote for the Republican candidate. And we can say, based on this based on this interaction term, if education is increased by 1 unit, then this kind of change in probability is even larger. Okay, so it increases this correspondence between ideology and vote choice. All right. If we want to kind of make more substantive, meaningful statements about actual probabilistic change, we can again use the rules that we used in previous videos. First, for the constant term, we have to plug in that constant term in our link function to get an actual probabilistic statement, and again, or a statement about probabilities. And again, keep in mind that here now we centered our predictors, so we can directly plug in our intercept into the link function, and we get a predicted probability of 0.43, right? So basically now, holding ideology and education at their median, and ideology at this kind of theoretical center of the scale, we have a predicted probability of 0.43 to vote for the or 43% to vote for the Republican candidate. Okay. Now, next, we can also look at the coefficients for our predictors. I'm just going to focus on ideology, but education, the predictor, of course, would be kind of equivalent, except for the fact that there's much more uncertainty relative to the estimated coefficient. If we want to interpret this in a probabilistic sense, the first step would be, again, to use our divide by 4 rule. We divide this coefficient by 4, and then we get an approximation of the maximum change in the predicted probability for a 1 unit increase in ideology. And this is now much larger because we rescaled ideology, right? So holding education at 0, at the median level of education, a 1 unit increase in ideology has a maximum predicted increase in the probability to vote for the Republican candidate of 0.3, right? So 30% or 30 percentage point increase in the probability, which is quite substantial, okay? So this is already quite a large effect for, or a large coefficient for ideology. But as we have seen based on this interaction term, this effect is also moderated by education. Okay, so if we want to kind of evaluate this interaction term in a probabilistic sense, one thing we can do is if we add our interaction term to our coefficient for ideology and divide it by 4, this basically tells us or gives us an approximation of the maximum change in the predicted probability for the case where education is now increased by 1 unit. Okay, that's why we add an additional interaction term or the coefficient for B4 to our original kind of main effect for ideology. Okay, and again we apply the divide by 4 rule, and we see now when education is increased by 1 unit from 0 to 1, the maximum change in probability for 1 unit increase in ideology is not 0.3, but it's 0.36. All right, so we see a stronger correspondence between ideological self-placement on the one hand and voting for the Republican candidate on the other hand, which is consistent with this kind of simple theory that we wanted to test. Okay. Now we don't only want to use this rule of thumb and just evaluate the coefficients, but we also want to actually visualize those effects. We can basically use the same code that we looked at previously to plot the raw data as well as our fitted logistic curves. We just have to basically take into account this interaction term when we plot the actual logistic curves, right? So the beginning here is the same sets of command. We're adding our, we're first plotting on the x-axis our main predictor, in this case ideology that we're interested in, and on the y-axis we have our vote choice, which again is just 0 or 1. And we add 2 additional functions. These functions now not only take into account basically the effect of one predictor on this linear, or of one variable on this linear predictor, but actually also take into account this interaction term, right? And in order to take into account this interaction term, what we have to do is we have to basically pick certain scenarios for our second predictor that is part of this interaction. And in our case here, we're basically just comparing observations where education is equal to -1 to education being equal to 2. Okay, these are just scenarios that I chose. Basically going remember in the original scale, education was scaled from 1 through 7. Since we median centered it and subtracted 4, this would be a change from 3 to 6 on this original education scale. Okay, so moving beyond the median and education levels, right? We could look at different scenarios. It always depends on your substantive question and your theoretical question, what comparison makes most sense in order to kind of convey the substantive implications of your results. Okay. Other than that, the functions here are fairly similar to, or the way these functions work is the same as in the previous videos where we plotted these logistic curves. Again, the only difference is that now we don't only have one input here with our slope coefficient, but we have in addition our second predictor, and we have our interaction term where we again include the coefficient of the interaction term as well as the value of the moderating variable that we're basically set constant, and then our independent variable that ranges in our case here ideology from -5 to 5 because we rescaled it. Okay. And then we add some text labels to kind of identify each of those logistic curves. Okay. And this is the result of our plot. Again, we see on the x-axis we have our ideological feeling thermometer. On the y-axis we have vote for the Republican candidate, which is either 1 or 0. Okay, and now we not only have one logistic curve, but we have two separate logistic curves with varying slopes due to the interaction term that we included. Okay, so basically we can say now here for education being equal to -1, we have this solid logistic curve. Okay, we still have a positive association or a positive effect of ideology on the predicted probability to vote for the Republican candidate, but kind of consistent with our theory, this change in the probability to vote for the Republican candidate is much stronger when the level of education is higher. Okay, and this is the dashed line here for education being equal to 2. We see a much stronger correspondence between ideology or self-identification with these ideological labels and actual vote choice. Okay, so this again is consistent with our theory. And now we kind of visualized how this kind of change in effects on the probability to vote for the Republican candidate actually kind of plays out in addition to visualizing the original raw data. Okay, of course we could further kind of enhance this visualization. We could take into account uncertainty by taking draws from our posterior distribution, the same way we did it with the original logistic curve, but then adding basically multiple lines for each of those cases. Okay. So this concludes our set of videos on visualizing logistic regression results and interpreting those coefficients. I hope these videos are helpful also for your problem set. In the next video, I'm going to talk a little bit more about choosing different scenarios for predictive simulation and predictive comparisons, right? Because here I kind of went through this fairly quickly, but we had to choose different scenarios for education in order to visualize kind of the change in the predicted probability conditional on ideology. Okay, and so we'll talk a little bit more about how we can choose these different scenarios and what kind of comparisons are most useful if we want to ultimately communicate our substantive effect sizes. Okay, so that'll be the topic for the next video.